In the first part of this video series, we saw how to set up an on-prem Kubernetes cluster with Flannel using Hyper-V and Windows and Linux worker nodes. In the second part, we saw how to add the MetalLB load balancer to our cluster and configure the Nginx-Ingress and how to generate the SSL certificates using the Cert-Manager. In this part, we will see how to deploy an application to our on-prem cluster using Azure-Devops. First, we will going to review one simple build process for a sample application. Afterwards, we will see how to create the Kubernetes service account and configure the service connections for the Azure DevOps. Afterwards, we will see how to handle different environment and basically the variable substitution using the Kustomize. And at the end, we will create the release pipeline for our deployment. The source code of the app is on the GitHub and you will find it in the comment section. It's a really simple app. It's a .NET Core app, almost out of the box. What is important for us is the Docker file in here. It's also basically a standard Docker file which comes with the Visual Studio. And we have some variables, environment variables, which is defined in here. The build process is really simple. You will find it in the pipeline build pipeline. Here the tasks are really simple. We will use the Docker Hub. In this example, I have used a private repository to be able to show you how to handle working with the private repository in the release pipeline. So here at the first step, we need to log in to the Docker Hub with the existing service connection, which I have created in the Azure DevOps. Afterwards, we will use the Docker file to build our image and add some tags to it. In this example, I have added 2 tags. I simply use the build ID and the source version. That is not something that you may want to use for the production. If you want to use it for a real work, you may want to use some versioning mechanisms like Git version or something similar. Afterwards, we will copy all of the manifests in this directory, and we use these manifests for the Kubernetes deployment. And at the end, we will publish these manifests as artifacts, which can be used in the release pipeline. So now to Azure DevOps. In the Azure DevOps, I have created one project, and here I am using the same repository, and here I have imported the pipeline that we saw, and in the pipeline you can see the artifact will be created in here. And it includes the manifest which will be used in the release pipeline for the Kubernetes deployment. I want to mention also one thing about the agent. I am using an on-prem agent, which is in the same network as my Kubernetes cluster. On the agent, I have Docker, and I also added some custom capability. That means using this agent, I can build the project and push the resulting images to the Docker Hub. And on this agent, I also have kubectl installed, so I can use it also for the deployment. To be able to release to the Kubernetes, you need some service connections. I have a service connection for the Docker Hub. If you want to create one, it's pretty simple. You will just find it in here for the Docker registry. You will use your Docker ID, and if you have two-factor authentication enabled, you need to create API secret and use it in here. You need another service connection for the Kubernetes. You can create it like this. Kubernetes, and it depends on your provider. If you have Azure subscription, you need to log into to the Azure portal. Afterwards, you will see the options in here, and you can choose your subscription and configure it like that. But now we have a local cluster. So what we need to do is going to the cluster on the master node and get the URL from the kubeconfig. That means in here, I will say my URL is something like that. And I can put it exactly like that in here. As I mentioned, my agent is running on the same network as my Kubernetes cluster. So the agent will have access to this local IP. Afterwards, we need some service account, and we need a secret from this service account for this configuration in here. To do that, you need to create the service account for the build or release agent. For that, I have some script in here and one YAML file. These are basically the same instruction that you see in the Azure DevOps. For the YAML file, you need to create the service account and use the cluster role binding to add this service account to the cluster role. And you will find the documentation also on the GitHub, on the Microsoft repository. You will see some example in there. So what you need to do is just download this file and use a kubeapply to create the service accounts. I've already done that. That means if I get the service account, from this VSTS namespace, you will see the DevOps user is already there. So the next step is to find out the secret. So that is my secret for that service account. And in the last step, we will use this secret. We will output this secret as a JSON, and we can use it in the service connection. So we can copy this and paste it here. You will give a name to it and save it. So I have done the same in here, as you can see, and I am using it in my release pipelines. Before I continue with the release pipeline, I want just to mention something. If you are using AKS or EKS or any other cloud provider, you may want to use the environment. On the environment for the Kubernetes, you can configure your environment in here. If you are using the Azure Kubernetes, you can choose that, or if you have another one, like example, in our case, the local on-prem cluster, you can define it exactly in here. You can define the namespace in there. For example, here I will choose the namespace test. And here you need to specify the server URL and basically the same thing that we did in the Kubernetes service connection. Unfortunately, I cannot use it because it won't use an agent, and it will try to connect to the cluster, and I don't have any public domain address for my cluster, so it's not accessible in this case. That if you have a public domain and your cluster is accessible from outside, you may want to go with this option because it has a lot of benefits, and it will give you much more better overview on your environment, deployments, and etc. Back to the release. Before we continue with the release, I want to show you how to handle variable substitution for different environment or different configuration for different environment. If you check the source code, inside the deployment folder, we have a kube manifest. In this case, we are going to use Kustomize. Kustomize basically allows you to apply patches in some base configuration. Example for the app, I have an app deployment. It's a simple deployment. Afterwards, I have ingress configuration for my app with the domain name in here. And afterwards, I have a service and I have a customization file in here. The Kustomize is now integrated in the Kubernetes, in the kubectl, and you can simply use it. And Azure DevOps has a task for working with the Kustomize. So basically, in the customization, we will reference all these three different YAML files. Then I have an environment folder. I have defined two environments, dev and QA. In dev, I have again the customization. Here I will reference all of this YAML file from the app folder, and I will specify the patches that I want to apply to these files. In Ingress, I want to change the host name to dev.linuxweb. In the replication, I want to say on the dev system, just use one replica. And in the variables, I have defined the variables for the dev environment. There is one simple variable and there is one secret, which will be read from the Kubernetes secret. It's the same for the QA. In the QA, in the Ingress, I want to patch the hostname to qa.linuxweb. And I want to use 3 replica instead of 1. And in the variables, again, I have defined the different variables and here the different secret for the QA. So how it works is basically we will specify the environment. The Kustomize will start from here. It will look in this folder, in the app folder, and it will search for the customization YAML file. From there, it will combine all these files together. Afterwards, it will check the patches and apply the patches to all of the files from top. So it's pretty simple, it's clean, and with this you can have different variables for different environment. So basically we will manage all of our variables in the code, and for the secrets we will use the Kubernetes secrets, and we can use the release variables to deploy the secrets to the Kubernetes. I have also another folder in here, infra. It's really simple. In here, I will create 2 namespaces, one for dev and another one for the QA. So now for the release, I have 2 pipelines. The first pipeline is the infra release. I need to run this before the application deployment, and it just create this 2 namespace for dev and QA in the cluster. Basically here we have one task. We use the manifests from the artifact. And here in the task, I am using the Kubernetes manifest task. You can also use kubectl and run the kubectl create namespace command, or you can just use this YAML file and deploy it to Kubernetes, and it will create your namespaces. So it's pretty simple for the release pipeline. For the application release, again, we have the Kubernetes manifests in the artifacts, in the generated artifacts, and we have defined 2 stages, one for dev and another one for the QA. I've defined 2 variables. One is for the environment name, or basically the Kubernetes namespace. And I have defined two secrets. I haven't locked them, so you'll be able to see them. And for the tasks, for the dev. First, I'm using the on-prem agent, and as it demands, I specified this kubectl, so I can make sure that it will use the correct agent that has a kubectl. As a first task, we need, because we are using the private repository, we need to create the image pull secret. Here we will use the same task. I will show you the task. That is this deploy to Kubernetes. Here we need to specify our service connection. Afterwards, we specify the namespace. And basically here it will be dev, and the type of the secret is the Docker registry. And we specify some name, which the secret will be saved under this name. And at the end, we need to specify the service connection for the Docker registry, and in this case is Docker Hub, which we have created before. So it's pretty simple. It will create this secret for the Kubernetes to be able to pull images from the private repository. Afterwards, we will use the create secret action to basically deploy our secrets or secret variables. The namespace again will be in here it will be the dev. The secret type this time is generic. We will specify some name for the secret. This name is exactly what we have defined in our manifest. That would be this one, dev app secret. It's the same that we have here. And here we will use these variables that we have defined in the release pipeline. So here we will use inline. You can define multiple like this and create a one secret for all of your secret variables. I'm using on-prem, so everything is on-prem, so I will use this one. You may want to use a Azure Wallet or another mechanism to save your secrets. Afterwards, in the next step, we need to apply the Kustomize. For applying the Kustomize, we need to use bake. And the render engine can be Helm, Compose, or Kustomize. Using the Helm chart could be a little bit complex, so I'm using the Kustomize. It's integrated already in the kubectl, so it's pretty simple. For the Kustomize path, you need to specify the folder path of this customization file which you want to use. And it will be inside, in this case, it will be kubemanifest environments, and here will be dev. What is really important is to set the output variable. The output variable will be the name that you gave in here, dot manifest bundle. What will happen is this bake task will apply the customization as I explained before and save the result inside this reference variable. So I will name it bake.manifest bundle. And for the deployment, I am using it in here. So here we have the whole manifest, which is already patched with the environment. And here we will use the deploy action. We specify the we will specify the connection, service connection for the Kubernetes, the namespace. In this case, it will be dev, and we use the image secret that we have created before. And we need to specify which version of this container we want to use. So here, as I said, I am using it as simple as it can be. I just use the build ID. So with this, I make sure that the correct version of the created image is used. So that's it. We have the same thing for the QA. It is exactly the same, just the variables are different for the QA. Yeah, that's it. So if we we can create a release and deploy it. So here the artifacts are downloaded. Here it will create the image pool secret. And here we will deploy our secrets for our secret variables. In this case, you will see the value because I haven't locked it. And afterwards, it will use the customize or this bake action to patch the environment variables. And afterwards, it will use this patched version for the deployment. So the deployment is done. That means I should be able to call the URLs. That is for our dev environment. You will see the variables are working correctly. And for the QA, it's also fine. You can also check the Kubernetes master. You can get the deployment like this. For example, for dev, and here when we can check the environment variables, and as you can see here, we have correct versions, which comes after the application of the Kustomize. And if you scroll to top, you will see also the metadata about the release, which can be useful in failure cases. So that's it. I hope you find the video useful. Thank you for watching and see you soon.